Alright guys, Stephen here, and what I want to talk about this time is Jinja or Jinja2 templating. What is Jinja2? So it is a templating platform that allows us to augment kind of common syntax with individual bits of data from a YAML file. Now what do I mean by that? Now, we looked at this topology last time and we essentially constructed a YAML file that would describe the entirety of the topology, drilling down into individual devices and so on and so forth. But having a YAML file that describes information or characteristics of a device is only half the battle. Okay, and what I mean by that is, if we look at this YAML file, we can see that each device has got its own subsection, and in there you've got things like the management IP address and the management VLAN. But having that interface or having that information stored in one place is only really half the battle. What we have to do is we have to augment that with syntax so that when we send it to devices, those devices know in what context we're giving it this information and therefore knows what to do with it. Now, if we have to write a script that, or had to write out these commands on the fly and just essentially go and manually reference this YAML file, then the YAML file, it's of limited value to us. But luckily, we've got a tool called Jinja in which we can specify a template, and then for each device, we can draw in details about that device and put it in place of placeholders. Okay, so we can type common syntax. So, for example, in order to apply an IP address to interface VLAN 10 for the purposes of managing these devices, we would have to go into, if we were programming it at CLI, we would have to go into interface VLAN 10, then once we're in VLAN interface configuration mode, we would have to say IP address. In the case of core 1, we can see it's 10.10.0.1 255.255.255.0. So with Jinja2, we can take that common syntax, so the IP address part, and we can then insert placeholders, and Jinja2 will render those placeholders with the values for the IP address and subnet mask of the management interface, but it will do it relevant to the device that we're talking about at any given moment. Okay, so to give you an idea of kind of more precisely how this works, again, we'll use the YAML file that describes me. It won't construct anything other than a series of fairly mundane but coherent sentences. Okay, but it will give me an opportunity to kind of talk about exactly how this works. Okay, so to go with this YAML file, I've also written a Jinja2 template. Okay, and from looking at it, it's not difficult to understand what Jinja does. Okay, so we can see on the top line here, it says, hello, my name is, and then we've got opened and closed curly braces with the string full underscore name inside it. Now, in this YAML file, we can see that we've got a key called full name, and when this is rendered, all that Jinja is going to do is replace this with the value of that key. Okay, same will go for age. So I am, open and close curly braces, age in between them, outside that years old. So Jinja will render this part of it, the braces and their contents, with the content of the age key in this YAML file, and then it will just work down, repeating. Now, the benefit of Jinja2 is that it was actually developed for Python, okay, and that means that we can essentially migrate some Python logic into a Jinja2 template. Now, what does that mean in practical terms? What it means is we can use Python logic, so conditionals and loops, in order to kind of go over repetitive parts of a template. So if I've got 24 interfaces on a switch, I don't have to write a template that on a case-by-case basis populates with the details from the YAML file. Okay, so to show you what I mean here, okay, we can see if likes, so if statement, that will yield a boolean result. So if there is a key called likes in the YAML file that this Jinja2 template is referencing, which I know there is, so yes, this bit is a little redundant, but it lets me show you what I'm on about. So if there's a key called likes, there is, so that yields true. We know that in a case like that, anything that is down and indented in Python executes. Okay, so if this is true, which it is, then for things in likes, okay, so for each of these things, print the line I like and whatever things happens to be at that particular iteration in the loop. Okay, now the word things there is completely arbitrary. It could say anything. It could say sausages, whatever. Okay, as long as it's consistent. Okay, and then when you break the loop or break the if statement, things becomes available to use again, so you can use it further down. Okay, so we can see here that once we exit out of this loop and end the if statement, it just prints the plain old line. However, then there's another bit of logic here. Okay, it says if dislikes. Again, I know that there is a dislikes key in this YAML file, so that will yield true. Then anything here is going to be executed. So for things and dislikes this time, print the line I dislike and whatever things happens to be at that iteration in this loop. Okay, so it will print I dislike winter, mushrooms, blah blah blah. Okay, now the way that you denote within Jinja2 templates that you're going to be using a bit of logic is to do a single curly brace followed by a percent symbol and then close it off after you've made the logical statement. Okay, and the same goes if you're nesting logic. Okay, so if you say if likes for things in likes, both of those logical statements have to be enclosed in that curly brace and the percent symbol. Anything that you're applying as a result of the running of that logic or of that conditional doesn't need to be anything done in any particular way. But same with here, when you're substituting a value in from the conditional statement or the loop, then you have to enclose it in double curly braces. Okay. Now, when we run this, as I say, it is going to produce fairly mundane statements. Okay. In fact, what I also need to point out is that just like in Python, where we can call the value from within a nested dictionary by kind of drilling down and specifying a specific location in the dictionary, we can do that in Jinja2 as well, because it is just using pseudo Python logic. Okay, so we can see my sister is called. Now in here, my sister's name is the value of the siblings key, which is here, but that resides, siblings is a value to the family key, so it resides inside the family dictionary. Okay, so I have to specify this. So my sister is called family, go to this level, go to the siblings value within it, and substitute out the value, and then the same goes for my mum and my dad. Okay, now when I run this, as I say, it'll be pretty boring, but it will give a perfect example of what I'm talking about. Okay, so there we can see it. Hello, my name is Stephen Jones. It isn't really. I'm 32 years old. I am really, unfortunately, and so on and so forth. Okay, not a problem. Now, in terms of actually writing a Python script that will do all this, it's really straightforward. Okay, we know from the previous video that you import YAML if you want to kind of open a YAML file in memory and have that available to Python. And that part is all the same. So we say with open, open brackets, specify the path to the YAML file, comma, R in quotes says open it as read only. So we don't intend to write to this YAML file, although you can do that. And in later videos, I'll show you where that might be beneficial. We store it as a temporary variable. We then create another variable called Stephen_data. That variable its contents are the result of using the load method of the YAML library against the variable named Stephen or the YAML file. And then this is, as I say, not necessary. You can skip this out if you want, but I do anyway. We just specify what loader we want to use because the YAML library comes with a couple. In terms of the Jinja2 and calling that into your Python script, you create a variable. Its name is arbitrary, so I've created this and called it template_dir. That equals, specify the path to the directory that the Jinja file is in, not like this. Okay, so here we actually specify the path all the way to the file. At this point, we are going to just specify the directory, which will become handy at later dates when this maybe gets a bit more complex. As a result, you can then say, well, what if I've got some Juniper devices and I've got some Cisco devices? Well, as long as you put the templates for each of those devices in the same directory, then you can just call in whichever template you need at a given moment or for a given device. Okay, now here I specify merge. This might not be necessary for you, okay? So it's just a variable, but its contents, I'm just saying take Stephen data, which is, as we can see here, the result of opening this file ultimately. And then I specify a jump off point, okay? Now you don't need to do this, okay? But what I've found is that when you start looking at topologies, it becomes handy to not just have a list of all your devices and have them have their own dictionary. It's handy to have them segmented in terms of, okay, well, here's details of all devices. At the same level, here's a list of devices that are in the access layer. Here's a list of devices that are in the core layer. And doing something like this ultimately is just in the same vein, okay? So merge is Stephen data, the Stephen key. So Stephen data is this whole file, the Stephen key here. So merge essentially contains this, okay? Now, then I specify template and underscore env. Again, that's arbitrary, but it simply allows me a method or a way to say environment, which is essentially a method built into the Jinja2 library. So we can see I import it up here. Okay, so from Jinja2 import environment. Environment lets me set file system loader, which I've called in as well. I then specify the directory in the file system that I want to load. Trim blocks is true, lstrip blocks is true. Okay. Now, this is the part of the script that essentially does all the spade work. Okay. Now, template, I'm just going to specify template equals template underscore environment. So it's going to see this and go to the directory .get template, and within this directory, which is here, it's going to get the template named Stephen.j2. Okay, so that's the template loaded in. Then I created a variable called complete, and complete is equal to the result of taking that template, rendering it with the contents of merge. Okay, so I render the template loaded here, Stephen.j2, this with the contents of merge, which is this. Okay, really straightforward. It might seem a bit finicky or footery to begin with, but once you do this once or twice, it is easy. Okay, and then I'm just going to print the result of complete, and that's what you see over here. All right. Now, the benefit of this, as I say, with regards to network automation or network devices, is that you might have 100 devices. So this YAML file about me is solely about me. Okay, you might have 100 devices, and this Jinja2 kind of platform, along with the ability to use logic, like conditionals and like loops, means that you can essentially have one template for example, each platform from a vendor. Okay, so I might have a template, in fact I do have a template that renders in contents from a variable, but the template itself is written in NXOS syntax, so Cisco Nexus syntax. I've got one here which you're going to see that renders, but the syntax used is for iOS. Okay, so you have two templates in that case. The syntax for those is relevant to whatever platform it's going to, and then because you've got conditionals and loops and you can use Python logic, you don't need anything more than that, because essentially the Jinja template is going to look and see, okay, well, does the data about this device in that YAML file have interfaces that are in shrunken mode, and if it doesn't, it'll just skip by it. Okay, so you only really need those two, okay, and you can build them out to do what you need. Okay, so let's have a look at the file that's about the topology. Okay, so there are bits in here that are going to be common to all devices, and when it's common to all devices, you don't need to use any sort of fancy logic or anything like that. Okay, and then when you're using information from the YAML file that is particular to a device, the same rules just apply. Okay, so here we can see host name. Okay, so in this, the Python file that I have written that renders the topology Jinja template, it's going to loop over every single device in the YAML file. Okay, there's more than one. The one about me only has information about me, but the topology file, that's got multiple devices in it. So the Python file, and the Python script anyway, is going to loop over every single one of these devices, and depending on what device is the subject of the loop at a given moment, it's going to switch out and just put in its host name like we've seen before. Okay, again, all of this, the VLAN information and the EIGRP information, that's all common. Okay, it's a kind of catch-all network statement. I'm not going to be particularly specific because it really doesn't suit my purposes for the sake of this video, so we'll just send that to every device. Now, here we can see banner, message of the day, really familiar command, host name, so we'll switch it out with the host name for the device that is a subject to the loop at that moment, and then it's going to send the string banner created by NetMiko, and it'll close it off so that you've got your escape character as well. Now here we've got the Python logic that we've seen previously. Okay, so curly bracket or curly brace, percent symbol, logical statement, close off the percent symbol in the curly brace. This is a little bit different, however. Okay, so for interface config in interfaces.items, the .items method in Python is built in. It replaces .iteritems if you're familiar with using Python 2. But what it essentially says is that I'm going to unpack a nested dictionary or a dictionary, okay? And at any given moment, I want one variable to hold the content of the dictionary at one level, and then when I take a step in, I want that content to be held by another variable. Okay, so in this case, if there's a key called interfaces, that's true. So it's going to step down and start executing this code. Then for interface config in interfaces.items means that interface at any given iteration in a loop will be held by the values at this level, and config will hold all of this. Okay, and that becomes important as we step down. Now we then have another if statement. So if config, which is the content of this, okay, if that has a key called mode, okay, then do the next line. Well, there's a key called mode, so we do the next line. Okay, if config mode equals access, then do these lines. Okay, or elif config mode equals trunk, do these lines. Okay, and in here we can see again we're just looking up the content of a key. So config encapsulation, config is this, encapsulation is this. Okay, and the instance where you've got access ports, then you can see here that access 2 has config mode is access. Well, in that case, if the config mode is access, switch out config mode for access, switch port access VLAN, switch it out for config VLAN, which is this. Alright, now then when you just need to make sure that you close off all your ifs and all your fors, otherwise Python will throw an error when you come to run it. And again, there's no nested dictionaries from this point on, so it's simply going to say int management interface. So in the case of access 2, management interface is VLAN 10, as it is with all devices. No switch port, not necessary because it's a VLAN interface, so get rid of that. No shut, IP address, management IP address, management subnet, and it will switch it out. Alright, with the contents of in access 2's case, these two keys. Alright, now I'll run this, okay, and we'll see essentially that for every device it's going to generate a template, and then in the next video we'll look at methods of getting these templates to devices. We will cover NetMiko, Napalm and non-near. I was asked the question, why cover NetMiko and Napalm on their own? And it's a really good question, but they make up part of non-near. They are tools that non-near has available to them, and then non-near just makes executing them so much quicker. Okay, but we'll run this in the first instance, we'll see the templates, and we'll get a proof of concept, I suppose. Right, so here we go, let's pick a random device. Let's go distro 2. Okay, so distro 2. Right, here's distro 2. So here's a template that's been rendered as a result of the Python script. Hostname distro 2, hostname distro 2. Compare that to there. Hostname distro 2. These are all sent to all devices, so we're not really interested. Okay, this is where here is where it starts to get a little bit intricate, but we can error check it. So we can see that all of this has resulted, all of this more specifically, has resulted in these configurations. Okay, so let's check these. We can see that they're syntactically correct. This is Cisco iOS syntax, but let's see if it's correct when compared to the YAML file. So distro 2 interface gigabit 00 should be a trunk with .1 encapsulation and with all the VLANs that we stated up here allowed. So interface gigabit 00, switch port trunk allowed 1, 10, 20, 30, 40, 50, 60 and 70. 10, 20, 30, 40, 50, 60, 70 for the purposes of being complete. 10, 20, 30, 40, 50, 60, 70. So that's all good. And that repeats on down, okay, just for the purposes of being thorough. Okay, let's look at an access device to make sure that the configurations correspond when we've got access ports. So access 2, where is access 2? Here it's here. Okay, so access 2, hostname access 2, all of these VLANs exist. Okay, wouldn't really need that, I suppose, in the access switches, but I could get rid of that with a conditional. Okay, access 2 banner created by NetMiko. Okay, so the interfaces, we've got gig 00, which is a trunk, and we can see that here. Access 2 gig 00 goes to the distribution, so it should be a trunk, and it's specified in the YAML file that it's a trunk, and lo and behold, gig 00 switch port mode trunk encapsulation .1q, and then we allow all the VLANs that we created previously. Alright, now the benefit of this is that when you are hopefully labbing things up, whether it's network automation that is the actual intent for the lab or not, this is really handy. So in my EVNG, I've got what I would call a base template that is essentially this. Sometimes they're a bit bigger, sometimes they're a bit more kind of complex, but irrespective of what I'm doing, if it was this and I want to lab EIGRP, I can use a Jinja template to essentially get a basic EIGRP topology in place really, really quickly, and then I can start labbing up stuff that is maybe bespoke to that lab, or start doing what I want to do. If I want to do an OSPF lab, I've got a template that will send OSPF basic config to these devices. Easy. Okay, and the benefit is that you have then got templates for every single device that you can give to tools like Napalm and NetMiko in order for them to do their stuff. Alright, and we'll look at those in the next videos. I think NetMiko first. Alright, thank you. Bye.